want to share with you concerns the age of the earth, the age of the universe. The various theories of evolution declare that the earth and the universe are billions of years old. Evolutionists say that we are just the result of a cosmic accident, that we are just thinking animals without specific design or purpose. In school, most of us were taught that life began by random chance chemical reactions. Yet when we see the beauty of the earth, we see the complexity of the living organisms that occupy it. Can we really believe that this is all just an accident? Throughout the world, we are presented with the evidence that calls into question evolutionary beliefs and the assumption of an old age for the earth and the universe. Over the course of this program, we will present to you evidence that will shake the foundations of the evolutionary worldview. Evolutionists say that the Earth is, in fact, millions and billions of years old. First of all, you have to understand that they have no proof for this whatsoever. They simply claim it. And you have to realize that evolutionists live and die by 8 words. Give me enough time, and anything can happen. Those are the 8 words by which evolutionists live and die. We might call it the evolutionary mantra. You see, in spite of anything and everything you can show an evolutionist that evolution is not true, they will simply respond by saying, give me enough time, and anything can happen. Now, I was once asked to write an article for a publication. When you're asked to write articles for publications, sometimes they give you the title of the article and say, we want you to write it. Sometimes they say, pick your own title and write the article. And I was given the title. The title was to be, how do you date a rock? I mean, let's think about this. Is there anything about a rock that will tell you how old it is? Is there anything about the size, feel, shape, smell, taste, weight, mass, specific gravity, density, chemical composition? Is there anything about a rock that will tell you how old it is? And of course the answer is no. There's absolutely nothing about a rock that will tell you how old it is. As a matter of fact, I can go outside right now, pick up any rock I choose to. I can claim any age I want to for it. You may disagree with me, but you cannot prove me scientifically incorrect. You understand? I can go outside right now, pick any rock I want to, claim any age I want to for it. You may disagree with me, but you cannot scientifically prove that I'm wrong. I mean, think with me. When you go outside and pick up rocks, do they come with little white strings attached, little white tags saying, I'm 10 million years old, and signed by a scientist who was there at the time? Excuse me? No. So let's think about this. Is there any way in which you can date a rock? The answer is no. There's no way that you can date a rock. And so what we want to talk about is, are the Earth and the universe really billions of years old, or are they, in fact, young? Now people will say, well, you know, the Earth is old. It all came from a Big Bang. Supposedly this Big Bang occurred some perhaps 20 billion supposed years ago. But is the Earth and the universe really 20 billion years old, or can you really trust the Bible to tell you the truth that it was created just 6,000 years ago? Now, you say a young Earth, young universe, and people will say, but wait, doesn't it have to be old? Because, and they will say things like, doesn't it take millions of years for rocks to form or for diamonds to form? What about stalactites and stalactites to form? What about polar ice caps to form? What about thousands of feet of rock layers to form? I mean, doesn't that take millions and billions of years? Or what about deep canyons to be cut into rock layers? What about dinosaur fossils to form? Doesn't that take millions of years? Or perhaps they say coal. Doesn't it take millions of years for coal to form? Or wood to fossilize? And the big one always is, doesn't it take millions and billions of years for light to reach us from distant stars? I mean, that's the big one that everybody asks. But I say it all has to be young. Now, that's a piece of natural opal from Australia. This is a piece of man-made opal from Australia. Under an electron scanning microscope, you can't tell the difference. But this artificial man-made opal was grown in that jar right there. Have I got your attention? You see, this is a natural piece of opal stone mined in Australia by hand. We want to take a look at, does it take millions of years for gemstones like opals and diamonds to form? And what about gold to form? Well, this is a natural piece of opal This is a man-made piece of opal. It was grown in this jar right here. You can actually see it growing right there in that lens. And it only took 3 months. Have I got your attention? You put the right chemicals in a jar, stick it up on a shelf, and you can grow an opal in 3 months. This gentleman is a Christian, a creation-believing scientist. He only does this as a laboratory experiment, but he's found out how to do it. But he doesn't sell them. He doesn't put them on the market. He doesn't flood the market with these things. But it only takes 3 months to get an opal. Or how about that rock right there? Come on, ladies, that's a nice rock. Oh, come on, that's the Hope Diamond in the Smithsonian. That's a nice rock, right? Yep. But evolution says it takes millions of years to form diamonds. Well, first of all, though, you really know that that's not true, because if you think about it, you know that we've been able to make industrial-grade diamonds for many, many years. It takes a few months. We simply subject carbon to heat, pressure, and so forth. But these are crude diamonds in the sense that they're not gem quality diamonds. They are diamonds, but they're only used for abrasives and grinding and so forth. But are you aware that in 2003 we found out how to make pure, super hard diamonds in only a matter of minutes? Now it takes high pressure and high temperatures, but it only takes a matter of minutes to get gem quality pure diamonds. Are you impressed? Well, think with me for a moment. You know how scientists are. If we learn how to do something, well, then the next question for a scientist is, how do you do it faster or cheaper or both, right? So the very next year, we found out how to do it at much lower temperatures, much lower pressures, and it only takes 12 hours. Is this interesting? Oh. Well, but you know how it is with scientists. If you learn how to do something, the next question is, how do you do it cheaper or faster or both, right? Well, in 2006, we found out how to make flawless, pure diamonds, up to 10 carats. It only takes 1 day. Today in the United States, you can go into a jewelry store, you can buy a diamond, you can either pay for a natural diamond or you can get a man-made diamond. They're of equal quality. And the man-made diamond is cheaper. And you now have a choice. And let's think about this. We now know that kimberlites, which are what you find diamonds in, actually come up from deep inside the earth at about 9 miles an hour. It only takes about 12 to 30 hours for this material to come to the surface of the earth. We found that out in 2000. And this is another report, 1999, showing that, again, it only takes about 2 to 8 hours for these materials to come to the surface of the earth. So I guess it really doesn't take millions of years to get a diamond. Is that correct? Have I got your attention? Well, what about gold? I mean, doesn't it take a long time for gold to form in nature? Well, actually, no. The massive Lihir gold deposits in Papua New Guinea could have formed in, quote, as short as 5 hours, unquote, claims geologist Greg Hall. That's January of 2007. Here, in a report that actually goes back to 1985, water sampled from over half a mile down by these geochemists contained, quote, 1,000 times the highest concentration of gold ever recorded in the surface waters of hydrothermal systems, unquote. But this was found at a geothermal power plant in New Zealand back in 1985. Today, we now think that there's approximately 53 pounds of gold being deposited in this gold mine while it's being mined. Well, 53 pounds of gold is no shabby, right? And what about stalactites, stalagmites? I mean, doesn't that take millions and millions of years to form? I mean, think with me for a moment. When you go to places, the caves, and limestone caves that have stalactites, stalagmites, don't they say to you, oh, it takes 10, 20 million years to get a cave like this? Is that right? Well, I'd like to see if it really does take 10, 20 million years to get a limestone cave like this. I'd like to see if you touch it, does it really take 1,000 years to grow back? Now, we're looking at, do stalactites and stalagmites form slowly or fast? Now, this is a photograph of some Mayan pottery made in the Americas. We know it was made about 700 AD. But in this photograph, you'll notice right here, this is a stalagmite coming up from on top of the pottery. Is that correct? So let's think. Here's this stalagmite on top of the pottery, so that means it formed in less than 1,300 years, is that right? So if it only takes 1,300 years for this stalagmite to form, I really don't think it takes 10, 20 million years, do you?
You go over here to, what's the one in Kentucky? Mammoth Cave? Or go to Carlsbad Caverns, and they say it took 250 million years. They did a study on these stalactites, and one guy said, you know, the fastest they can grow is 2.5 inches per 1,000 years. That's the maximum growth rate. I don't think so. Here are some 50-inch stalactites growing under the Lincoln Memorial. They did that in 40 years. There's a bat covered up with flowstone before it could even rot. There's 2-inch stalactites growing off a refrigeration shed in Pensacola, Florida. There's a guy in a building in Indiana built just 40 years ago, has huge cave formations in the basement of the building from water leaking through the limestone. There's a mine was shut down in Australia for 55 years. When they opened it back up to check it out, there were huge cave formations in 55 years. There's a pipe that was dripping water for 7 years, made a 13-inch stalactite. I thought it was 2.5 inches per 1,000 years. It's more like 2 inches per year. They broke off the stalagmite that was under it and gave it to me. It's in my museum. There's a parking garage built in 1997 in Texas. It was making stalagmites on the students' cars parking under it. They had to put up a drip pan to catch the water. A guy in Wyoming had a hot mineral spring on his property in Thermopolis, Wyoming. So he stuck a pipe in the ground. The water came out the top of the pipe and bubbled out the side of the top of the pipe, you know. But it had a little fountain. They called it the teepee fountain. Well, the guy died. They left the pipe sticking in the yard. As the pipe was there, it left behind mineral deposits as the water evaporated. How many have seen these mineral deposits? You get them on your sink up here? Okay. The guy died, and about 95 years after he died, after the pipe was stuck in the ground, I went to see it. Here it is, back in 1998. That would take some lime away to scrub that thing clean, don't you think? Yeah, a little bit. The guy down the street started his later. It's not quite as big, you know. But,
Or how about this? Now this comes from Australia. This is a man-made tunnel. We might call it a man-made cave. It was dug 160 feet deep into a basaltic or a volcanic hill in Australia in 1857. But here you see this beautiful flowstone. Here you see these stalactites coming from the ceiling. Now let's think. This photograph was taken in 1997, so it only took 140 years for these formations to form. So I don't really think it takes 10, 20 million years to get a limestone cave. How about you? And evolutionists will tell you, well, the polar ice caps contain perhaps 250,000 years of accumulated ice and snow and so forth. As a matter of fact, they will tell you that you can see the little lines in the polar ice caps and they'll say, you can see 220,000 lines there and so forth. First of all, that's not true. It's actually a lie. Now, it is true that you can see these little lines near the surface at the top and even down into the middle, but once you get down in the middle, the pressure of the ice is so great that those lines simply become invisible, and after that it's just, subjective judgment and so forth. And they'll tell you that these little lines in the polar ice caps, those are just like annual rings in a tree. You cut down a tree, you count the rings, and they say, oh, well, you can see 220,000 lines. They're just like tree rings and so forth. So this tells us that the polar ice caps are 220,000, years old. But I don't think so. I mean, when I was an evolutionist, I used to accept that kind of thing, but I don't believe it anymore. Let me show you why. Now this is a Boeing B-17 medium-range bomber from World War II. This is a Lockheed P-38 fighter from World War II. In 1942, 2 bombers escorted by 6 fighter planes left the United States to go to England as a part of the war effort in World War II. Now these planes cannot fly directly across the Atlantic. They don't have nearly enough fuel. And so what they must do is they have to fly first to Bangor, Maine. From Bangor, Maine, they fly to Newfoundland. From Newfoundland, they fly to Greenland. From Greenland, on to Iceland, and on down to England. Now, these 8 planes took off from the U.S. in 1942. They got to Greenland, and they fueled up on the west coast of Greenland. They started across the polar ice cap of Greenland, ran right smack into a snowstorm. This was a complete whiteout. They couldn't go forward. They tried to turn around, find the base they came from, couldn't find the base they came from. They decided they were going to have to crash land on top of the polar ice cap. Now the first plane went in with its wheels down, flipped over. Everybody said that's a bad idea. So the other 7 planes came in with the wheels up and just belly landed. Now, after the storm was over, the crews were rescued, but the planes were left there because it was much cheaper, much faster to just build new planes back in 1942. But in 1988, some enterprising American men remembered that those planes were up there, and there's a lot of money in antique aircraft, especially military, and so they decided to go up and get these planes, you know, rehabilitate them and so forth, make some money. And so they took brooms and shovels up there to find these planes. Now you have to understand, these planes are not heavy enough to sink into the ice. Wherever they landed is where they stayed, okay? So they crash landed in 1942. Planes stay exactly where they landed. Well, it's only been 46 years. Anybody want to guess, tell me how many inches, or if you prefer feet, of ice and snow they found on top? Anybody? You see, what we actually found was 250. In 46 years, 250 feet of ice and snow had formed on top of the planes. This is a picture of Glacier Girl as she looked when found 250 feet below the surface. They had to come back. They couldn't find the planes. They took back the brooms and shovels, came back with sonar and radar that would penetrate the ice, finally found the planes 250 to 270 feet below the surface. They actually had to come back with heavy equipment, bore these big holes all the way down 250 feet. They've actually disassembled her, brought her back up in pieces, reassembled her. She's one of the few flying P-38s in the world today. So let's think. It only took 46 years for 250 feet of ice and snow to pile up on top. That's 5.4 foot per year. Is that correct? I don't think those little lines in the polar ice caps are annual rains. I don't think those are years. I think those little lines are individual storms. That would be much more reasonable, wouldn't it? Oh. Now this is a picture of the Upper Grand Canyon of Arizona. And here you see hundreds and hundreds of layers of rock, right? I mean, it's a beautiful area. Now evolutionists would tell you that these layers could span millions and millions, even hundreds of millions of years, but I would like you to think about it something for just a second. First of all those layers you see here are sedimentary rock. Now what is sedimentary rock? Well, it comes from the word sediment, correct? So if I had a glass of water here and I threw dirt and sand into the water, whatever settles to the bottom would be called sediment, correct? So sedimentary rock is a water deposited rock. You remember from school there's only 3 kinds of rock: igneous, metamorphic, and sedimentary. All these layers of rock you see here are sedimentary rock. What you really see here are just layers of dried out mud. That's everything you see here. These are just layers of dried out mud. And I say it takes just 1 year to cut that canyon. That these are just the wet mud layers laid down by the flood of Noah, that this whole canyon was cut in just 1 year. Now, of course, you could argue with that, but let's just take a look at it. This is a picture of the south wall of the Grand Canyon taken at sunrise from several miles away. This is the Colorado River. Now, when you see these layers, you see hundreds and hundreds of layers here, is that correct? But they're all layers of dried out mud. Now, if you were to believe that all these layers came from individual floods, you would have to believe that about 1,000 floods of roughly equal depth occurred one after the other exactly the same way, covering hundreds of thousands of square miles. Now, does that even seem acceptable? That's a little tough, right? And I would like you to think about something with me for a minute. A good scientist always asks 2 questions. The first question is, what's there? Meaning, when I make a scientific observation, I have to adequately and accurately describe what is present, what is there. But the second and more important question in science is, what is not there? You often learn more by asking the second question than the first. Now, let's ask ourselves the 2 most important questions in science concerning the Grand Canyon here. What is there? Well, we have hundreds and hundreds of layers of dried out mud. Now, think with me for a second. If each of those layers was laid down by an individual flood, then there would have to be some time for each layer to be exposed before the next layer was deposited on top, correct? Right? If it's one at a time, one layer's, then there's a time of exposure, then a second layer, time of exposure, then a third layer, right? Now, if that were true, if each of these layers here seem flat, although they're not flat, they actually undulate and they twist and turn and meet each other at a 90-degree angle, and If you go to the north side of the canyon and you go up the North Kaibab Trail, there's a place where you can actually see one kind of sedimentary rock completely surrounded by another kind, like a donut, but the donut is surrounded by the kind of dried out mud that's in the middle. Well, if each of these layers is supposed to represent different ages, that each one was laid down, there was a period of time of exposure between the next layer being laid on top, then please tell me, why are there no soil horizons between the rock layers? I mean, if the rock layers have been exposed, we would expect some weathering, we would expect some of the rock to turn into soil, is that correct? But there's no soil horizons between the layers. Why are there no V-shaped erosion marks in the layers? I mean, think with me for a minute. If you have a layer deposited, rain falls, starts to etch a V-shaped erosion mark into the layer, then the next layer comes in, is going to fill that in, it's going to preserve it, is that correct? But there are no V-shaped erosion marks in these layers. There are no animal holes, there are no root holes. That's all missing. So what does that tell you? It tells you that all of those layers of dried out mud occurred in one year by a big flood called the Flood of Noah, and because there's no soil horizons, V-shaped erosion marks, animal holes, or root holes in the layers, it proves they were all deposited at one time.
It's always amazed me how two people can look at the same thing and come to opposite conclusions of what they are seeing. Two people can look at Grand Canyon. One of them believes in evolution. He looks at the canyon and says, wow, look what the Colorado River did for millions and millions of years. Christian stands there, looks at the same canyon, and says, wow, look what the flood did in about 30 minutes. Now, how was that canyon formed anyway? This textbook says over millions of years, the Colorado River has carved the Grand Canyon from solid rock. Now just slow down a minute. Kids, it is a fact Grand Canyon exists. How many have been to Grand Canyon? I taught Earth Science, studied Grand Canyon avidly. I like Grand Canyon. Beautiful place. Big hole in the ground. Now, there are two interpretations of how it got there. The evolutionists have an interpretation, and so do the creationists. The evolutionist is going to tell you that canyon formed slowly by a little bit of water and lots of time. Millions of years. The creationist is going to tell you, oh, the canyon formed quickly by lots of water and a little bit of time. The guys who believe in evolution are continually trying to erase the line between their interpretation and the fact column, and they want you to somehow think that what they interpret as evidence is now part of the fact. You got to really watch them on this. They're pretty slick. This textbook author does it just blatantly. He says, the Colorado River has cut through layer upon layer of rock over millions of years. Now just hold on a minute. I was in a debate one time, and this atheist said, Hovind, you're so dumb. Don't you know it took millions of years to make Grand Canyon? I said, well, sir, I taught Earth Science for years. I really enjoy studying Grand Canyon. I said, did you know if you built a dam across Grand Canyon, that would take a lot of dirt, by the way, but if you did, a huge lake would fill in behind it. Did you know some of the water from Montana drains through the Grand Canyon? It's a huge drainage area. I said, sir, did you know that in between these two red lines is what we call the snow line? There's a ridge right there. The Grand Canyon enters at the far right over here. The elevation of the river at that point is 2,800 feet above sea level. The river flows downhill for 270 miles and comes out the other side. And in between, while the river's flowing down, the ground is rising up and then slowly coming back down. It is so wide, 270 miles, that you don't notice it until you get way back and look at it from a satellite. But if you look at it in a cross-section, this schematic shows the difference here. The river enters right here and flows downhill and comes out the other side. It's actually going through a giant ridge, 270 miles long. At the highest point of the ridge, the river's at about 1,800 foot elevation, so it's nearly a 1 mile drop down into the canyon. Really big hole in the ground. I says, now sir, there are a couple things you ought to consider about Grand Canyon. I said, did you know the top of Grand Canyon is higher than the bottom? He said, yes. I said, sir, did you know the river runs through the bottom? He said, yes. I said, sir, did you know the top is higher than where the river enters the canyon? By over 4,000 feet. I said, sir, did you know that rivers don't flow uphill? I said, sir, did you know there is no delta? Nobody knows where the mud is that got washed out of there, but it's probably out in the Pacific Ocean. They can't find the delta for Grand Canyon. There is no possible way that river made that canyon. Grand Canyon is quite obviously a washed out spillway. There used to be two big lakes, Grand Lake and Hopi Lake, and they got too full one day, who knows when. I suspect shortly after the flood, maybe a few hundred years later, the ice caps melted or something, and the lakes got too full, and the water went over the top, while the ground was still relatively soft. Within the first few hundred years, washed out that canyon in a hurry. There are still beaches where the lakes used to be. They call them Grand Lake and Hopi Lake. The lake is long gone, but you can still see the beach line where the lake used to be. Grand Canyon is a washed out spillway, folks. The water got too deep, went over the top, and washed out that whole region in a real big hurry. So when they tell you it took millions of years, they're lying to you. It did not. It's not geophysically possible. If you look at the way most rivers come together, almost all rivers join at what are called acute angles, less than 90 degrees. You can look at any map of the world, nearly all rivers come together and keep going the same general direction. Well, if you look at Grand Canyon, the rivers on the lower left side join at acute angles, normal river pattern. If you look at the right side, the rivers go backwards and run into the channel and turn around and come back the other way. This is evidence of a big lake that is draining. Any farmer that's ever built a dam to hold water to feed his cows or something, or water his cows, will tell you, once the water goes over the top of the dam, it can wash it out in a hurry. And it doesn't wash away the whole dam, it washes one slot, wherever the water finds the weakest point. So the water's running backwards off the dam to hit the lower channel, turn around, come back the other way. Grand Canyon was not formed by the Colorado River, folks. Grand Canyon was formed by a flood. A lot of water with a little bit of time. There are zillions of stars out there. I mean, lots and lots of stars. And we haven't even seen them all. If star births, they ought to at least equal star deaths, and they don't. We see a star blow up about every 30 years. It's called a nova or a supernova. Well, then how come there are only 300 dead stars out there that we can see, supernovas? That's only a few thousand years worth, isn't it? There ought to be trillions of them, if evolution were true. Then they tell the kids the Earth formed from a hot molten mass 4.6 billion years ago. This is part of the theory, and it's in all the textbooks. 4.6 billion years ago, Earth cooled down, formed a rocky crust. I think that is stupid, and I'll show you why. Was the Earth ever really a hot molten mass 4.6 billion years ago, and it cooled down? This textbook says, as Earth formed, the surface was like the moon. There were hot pools of bubbling lava. I don't think so. My Bible says the Spirit of God moved upon the face of the waters. So the Earth was not created a hot molten mass. It was created under water, which means it has to be less than 212 degrees Fahrenheit or 100 degrees centigrade, or it wouldn't be water, it'd be steam. So the Earth was never a hot molten mass according to Scripture. Then when you look in the granite rocks, you find little tiny halos made of polonium. Now these polonium halos are absolutely amazing. Robert Gentry, a friend of mine from Knoxville, Tennessee area, he has been studying radiopolonium halos for a long time. I met him back in the year 2000 and went down to his laboratory and I got to see some of the halos through the microscope. These little polonium halos are interesting because they have a half-life of less than a few minutes. If the rock was hot, when the polonium, radioactive polonium decayed and sent out the little particles and made the halo, it would melt away. This polonium would have to be decaying in a rock that is already solid. So the Earth was never a hot molten mass. Get Robert Gentry's book if you want a lot more on that. But all over, the granites all over the world contain these polonium halos. So it is stupid to say the Earth was a hot molten mass. We have scientific evidence it was not. Here they tell the kids, though, the Earth was hot with large pools of bubbling lava, and that is just stupid. It can't possibly be true.
There are evolutionists who rely heavily upon radiometric dating processes to determine the age of a rock. You've all heard of carbon-14. And they say that you can date a rock, millions, billions of years old using these radiometric dating processes. However, that's not true. First of all, none of them work. Not one of them works. Carbon-14 doesn't work. Even the man who invented it, Dr. Libby, admitted it didn't work. They all start with 5 false assumptions, and carbon-14 has 7 false assumptions. Now, would you agree with me that if you have a dating technique based on 5 false assumptions or 7 false assumptions, then you're not going to be able to get a reliable date? Is that correct? I mean, that's right. And then would you agree with me on something? If these things actually worked, if they did, and you could use 2 different methods on the same rock, wouldn't you expect them to be approximately the same date? About the same age and so forth. Is that right? I mean, Agreed? If you could use two different ones on the same rock, if they work, they should be about the same, right? Okay. How about if I was within 10%? Would that be satisfactory? What do you want, 15%? 10s. Okay, well, I got 10's enough. Okay. Well, good. Well, here's the problem. You see, not only do these methods not work, there are major contradictions between different dating methods used on the same rock. For example, this is Sunset Crater National Monument. It is south and east of the Grand Canyon in Arizona. Now, anybody who knows anything about Arizona, New Mexico, that part of the United States would know that there's a large number of Indian ruins in this area. As a matter of fact, there are Indian ruins right in the park area. And so let's think. We know that this eruption can be dated at about 900 years ago. We can do that by tree ring countings because 900 is not a big deal. And we know that there were Native American Indians living in the area. First of all, there are remains of their houses and so forth are there. And also, in the cinder cones, in the lava flows from this eruption, we found native Indian artifacts. So we know that there were people living there at the time that the eruption occurred, and some of their artifacts were trapped in the material from this eruption. So, there were native Indian artifacts found in the lava flows and cinder cones. Now, this is volcanic rock. Now, when it comes to volcanic rock, the method of choice here would be the potassium-argon method of dating. And so, we potassium-argon dated some of this material, and the laboratory that did the work came up with a date of 210 to 230,000 years old. I think that's more than 10%. Am I right here? Oh. Or what about this rock? This comes from Australia. This is a piece of volcanic rock from an eruption in Australia. Inside the rock, when we cut it open, we found this burned wood. It's really charcoal. So let's think. This volcano erupted. The rock completely surrounded a piece of wood. There's no question there's no contamination here. The rock completely sealed the wood inside. Now, the heat of the lava caused the wood to burn. And so we were left with basically charcoal inside the rock and lava rock on the outside. Now, of course, since this is charcoal, you would use the carbon-14 dating technique. And the rock is volcanic, so you would use the potassium-argon technique. Now, understand, please, I don't agree with these dates. You do understand that. I believe the Earth and the universe are 6,000 years old. However, the laboratories that did the dates got for the carbon-14 date on this wood an age of 45,000 years old. Now, again, I don't agree with it, but that's what they got. The lab that did the potassium-argon date on the piece of lava got a date of 37 million. I think I see a problem here. I think that's more than 10%. Am I right here? Oh.
Carbon dating was not invented until 1949, in the last 60 years. So when they started telling the kids the Earth is billions of years old, back in 1830, they didn't tell them because of carbon dating. They never thought of carbon dating, never been heard of, okay? Why were they teaching the Earth is billions of years old 160 years ago? Well, because they needed billions of years to make their theory look good. The Earth was divided up into layers: Cenozoic, Mesozoic, Paleozoic, Archeozoic. Each layer was assigned a name, an age, and an index fossil. Then they said, now, we have to prove these layers are old. So they picked the numbers out of the clear blue sky, and any dating technique that comes along, like carbon dating or any other, has to match the geologic column or it's rejected. Only because the geologic column's been taught for 180 years now. So surely it's true. No, just because it's been taught 180 years doesn't make it true. But that's the logic those scientists will have. Well, we know the geologic column is established, therefore any carbon dates we get should match that. If they don't, we'll throw them out, and we'll keep testing till we do. They might have to test a sample 5 or 6 times till they get the number they want. Well, how do you know any of them are right then? If you're getting a different number every time, how would you know any of them are right? Radiometric dating would not have been feasible if the geologic column had not been erected first. Ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. Apart from very modern examples, which really are archaeology, I can think of no cases of radioactive decay used to date fossils. They don't date fossils by carbon dating, they date them by their geologic position. That's how it's done. This radioactive carbon-14 is different than regular carbon. It's produced by radiation striking the atmosphere. Sunlight strikes the atmosphere, slaps the nitrogen around, and turns it into carbon-14. So it all starts by the sunlight hitting the atmosphere. Just to give you the procedure here, about 21 pounds of carbon-14 is produced every year, and that is spread out all over the world. If you look at a periodic table, carbon and nitrogen are right next to each other. Nitrogen has an atomic weight of 14, carbon has an atomic weight of 12. But if the sunlight slaps the nitrogen around, it'll knock a few things off of it and it becomes carbon-14. So it still weighs as much as the nitrogen, but now it's considered a carbon. It's called radioactive, which does not mean it listens to the radio. It's just, it's unstable, and it's going to break apart. It does not like being carbon-14. It wants to get out of this situation, so it breaks down. About half of it will break down on a statistical average. About half of it is going to fall apart every 5,700 years, roughly. Now, while it is carbon-14, it's floating around in the atmosphere, like the rest of the carbon, and it latches onto oxygen, like carbon often does, and becomes carbon dioxide. And they hook up and they're happily floating around the atmosphere. And the plants are breathing in CO2. Animals come along and eat the plants. So the only way carbon-14 gets into the living world is from the atmosphere. It's produced by the sun, striking the atmosphere. Plants breathe it in, animals eat the plants. Probably during your lifetime you've either eaten plants or you've eaten animals that have eaten plants. How many have ever done that before? Like today for lunch, right? Okay. Everything we do is from one of those two sources. It's plants or it's animals that ate plants. Well, the plants are absorbing CO2. Some of it is radioactive. So if the atmosphere contains 0.0000765%, it is assumed that the plants also have 0.0000765%. Probably a reasonable assumption, and I don't argue with them. I just point out this is one of dozens of assumptions that can enter in to really mess up things like carbon dating. So probably you have 0.0000765% carbon in you, because you've been eating these plants or you've been eating the animals that have eaten the plants. So probably it's all balanced in nature. When the plant or animal dies, it stops eating, stops taking in more C14, it stops breathing. Okay? Now whatever it had is going to decay. It was decaying while it was alive, but now there's nothing to replace it. So what they do is they compare the amount of C14 in the fossil with the amount in the atmosphere and say, wow, this fossil's only got half as much. Therefore, it's been dead for one half-life, 5,700 years. Because it continues to decay after it died, but now it can't be replaced. So while it was alive, it should have had about 0.0000765%. If it's only got 0.0003825%, it's been dead for one half-life, or two half-lives, or three half-lives, etc. Great article came out from Institute for Creation Research. They're the ones that did the RATE project, ICR.org. They said, with their short 5,700-year half-life, no carbon-14 atoms should exist in any carbon older than 250,000 years. It should all be gone. Yet it's proven impossible to find any natural source of carbon below the Ice Age that does not contain significant amounts of carbon-14. Even though such strata are supposed to be millions or billions of years old, conventional carbon-14 laboratories have been aware of this anomaly since the early 80s and have striven to eliminate it and are unable to account for it. Lately, the world's best such laboratory, which has learned during 2 decades of low C14 measurements how not to contaminate specimens externally, under contract to creationists, they confirmed such observations for coal samples and even for a dozen diamonds. Now think what that means. The textbooks will tell you coal formed 250 million years ago in the Carboniferous era. And yet when they test coal, it still has carbon-14. How is that possible? If all the carbon-14 atoms would have disappeared in, say, 30, 40, 50,000 years, why would there still be carbon-14 atoms in coal? I got an idea. It's not 250,000 years old? Ooh, boy, they don't like that answer. They'll keep searching until they find another answer because they don't like that one for sure. And diamonds, which they say, formed millions and millions of years ago, they still have carbon-14 in them. And it's not possible to contaminate one of those things. I mean, that's the hardest substance we have. So how do you get carbon-14 in diamonds? Anyway, the guy said these diamonds even have carbon-14. It says this cannot be contaminated. Those constitute very strong evidence the Earth is only thousands, not billions of years old. But the carbon dating assumptions need to be pointed out. They'll say, well, we know carbon decays at a certain rate, and so we know if it's only got half as much, it's half as old. there's some assumptions that mess up everything. I'll show you how it works. If I said, we're going to fill a barrel with water. So I hand Leah the hose. Here, Leah, fill this barrel with water. But what you don't know is I have drilled holes in the barrel. While you're putting it in, the water's leaking out. The Earth's atmosphere is kind of like this barrel. It's always getting brand new carbon-14, 21 pounds every year, being put in. And it's always leaking out through decay. So the question would be, how long would it take to reach a stage called equilibrium? Now with a barrel, you can actually do the math and calculate. If I'm going to put in, a certain amount of water per minute and a certain amount per minute leaks out, when will I reach equilibrium and where? That can all be calculated, with a little bit of math. And with the atmosphere, they said, well, when would the atmosphere reach equilibrium? So the guys who invented carbon dating in the late 40s said, I wonder about this Earth's atmosphere reaching equilibrium. They did a bunch of studies on that and said, now if we took a brand new planet Earth, created it from scratch, poof, got it going around the sun, how long would it take to reach this equilibrium point in the atmosphere where the production rate and the destruction rate is the same? And they determined it would take about 30,000 years to reach equilibrium. I'm not sure how they did all that. You could probably see some of the rate scientists and figure that out. But then they made two mistakes, in my totally unbiased opinion. They said, number one, we know the Earth is millions of years old. Mistake number one. Number two, they said we can ignore the equilibrium problem because we would have passed that point 30,000 years ago. You know, they've discovered the Earth has still not reached equilibrium. Radiocarbon is still forming 30 to 40% faster than it's decaying. Now think about that. If radiocarbon is still forming faster than it's decaying, that means the Earth is less than 30,000 years old, number one. And number two, you can't carbon date anything. Because you'd have to know when it lived so that you could calculate when it lived. You would have to already know when it lived to figure how much carbon-14 was it breathing at that time. Doesn't work. If you find a fossil in the dirt, the amount of carbon can be measured, the rate of decay can be determined. I don't argue with either of those. How much was in it when it lived? I don't know. Has it always decayed at the same rate? I don't know. Has it been contaminated, sitting there in the ground for all these millions of years? There's no way to know those things. The lower leg of a mammoth was 15,000 years old, but the skin was 21,000. How can two parts of the same animal be different ages? Quite obviously, we know one of the numbers is wrong. So how would you know either of them are right? And if either one's right, how would you know which one? I see no way to tell. Well, let's see if it's getting better. 14 years later, they tested a living mollusk, a clam, and it was 2,300 years old. Still alive. In 1970, at the Nobel Symposium, they said, if a carbon date supports our theories, we put it in the main text. If it does not entirely contradict them, we put it in a footnote. If it's completely out of date, we just drop it. You mean they can pick and choose any numbers they want? Exactly correct. If the number doesn't fit what they expected, they throw the number out. 1971, freshly killed seal was 1,300 years old when they carbon dated it. Out of thousands of carbon dates that have been carbon dating times that they've done it, half of the numbers are thrown out. How do they know they're wrong? And also, how would you know the other half is right? If half your test results have to be thrown out, it ought to raise red flags in somebody's brain. Wait a minute. This is stupid. What are we doing? We're wasting our time here. No matter how useful it is, the radiocarbon method is still not capable of yielding accurate and reliable results. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. This whole blessed thing is nothing but 13th century alchemy. And I agree. That's 1981. I've got all these in chronological order. It never gets better. 1984, living snails carbon dated 27,000 years old. 1992, two mammoths found side by side. They carbon date them. One is 22,000, the other is 16,000. Which one's right? Or are both of them wrong? Or are both of them right? There is no possible way to tell. So when they publish an article in the paper and say, we found a dinosaur bone or a mammoth bone, and it was, 17,221 years old in 6 months and 3 days. Right, come on. You don't know that. They're making up this stuff. Just absolutely making it up. One part of a mammoth dated 29,000 years old. Another part was 44,000. You talk about a slow birth. That would be it, okay? I like this article from Rand McNally. The last 2 years, an absolute date was obtained for the Gandong beds above the Trinil beds. That's in Indonesia. It has the interesting value of 300,000 years, plus or minus 300,000 years. Boy, they nailed that one right on the head, didn't they? Plus or minus, 300% error. Living penguins were dated at 8,000 years old. Materials from layers where dinosaur bones were found are carbon dated 34,000 years old. But yes, dinosaurs ought to date, 70 million years old. A Russian scientist dated dinosaur bones at less than 30,000 years old. Hugh Miller from Columbus, Ohio, took in 4 dinosaur bone samples and said, would you carbon date these? And they charged like $600 to carbon date something. They carbon dated them and said they're less than 20,000 years old. He said, oh, by the way, these are dinosaur bones. They said, oh, well, then they're not 20,000. We've got to test them again. Why can't they be 20,000? They said, well, we know dinosaurs lived 70 million years ago, so if you had told us that, we never would have carbon dated them. One friend of mine died here several years ago, but he was doing a lot of archaeological work, and he dug down in this well and he found layers of burned wood, which is good to carbon date because obviously, it had carbon in it. And he put them in a baggie, sample number A, from such and such a layer. How many feet down, he labeled it A. Dug down 10 more feet, hit another layer of burned wood. A city had been destroyed, or 20 feet, whatever it was. He labeled it sample B. He took them in to have them carbon dated. Paid them the $600. They said sample A is, I forget, 3,000 years old, and this one's 4,000 years old. He waited 6 months, switched the labels, took them back in, same laboratory, said, I want you to carbon date these samples. Now, sample B, the lower one, is in the top bag. So just switch the labels, and they give them the same results, 3,000 and 4,000. It doesn't work. It's never worked. Here's things to consider about carbon dating. When the sample of, you date a sample of known age, it doesn't work. If you date a sample of unknown age, it is assumed to work. That's not science, okay? This guy said the rocks do date the fossils, but the fossils date the rocks more accurately. That's ludicrous, okay? And it all based on circular reasoning. 80% of the potassium in a small sample of iron meteorite can be removed by distilled water in 4.5 hours. Well, if you can take out 80% of it in 4.5 hours, how can you trust any dates you're going to obtain by that? Canadian Journal of Earth Science ran an article and said, in conventional interpretation of potassium-argon age, it's common to discard ages which are substantially too high or too low compared to the rest of the group, or with other available data such as the geologic time scale. There it is. If you test a sample and its number's too high or too low or doesn't match the geologic column, it gets thrown out. Well, then why are you wasting your time and money testing it? You already know how old you'd like it to be. Give it a number. Pick a number. It's dumb. Lava from Mount St. Helens was tested, which my sister lives just 60 miles from there. They tested the lava from Mount St. Helens, brand new lava coming out of the volcano. Grab a sample. How old is it? They tested it 5 different ways and got 5 different numbers. All the way from 350,000 to 2.8 billion. Notice, all 5 numbers are different, number 1, and all 5 numbers are wrong, number 2. They're wrong. It doesn't work. So again, when you test a sample of known age, it's assumed to work, and if you test a sample of unknown age, it is, we know it doesn't work when you know the age, but when you don't know the age, well, then they say it works. So
this is my favorite kind of fossil. Now, my favorite kind of fossil is called a polystrate fossil. And so a polystrate fossil is any fossil which penetrates through 2 or more layers of the fossil record. Now, they are usually tree trunks, but they're often bone. Now, here you see in this photograph from Australia, many, many layers. Is that correct? Everybody see the polystrate tree trunk? Well, if you can't, it's right there. But what's particularly interesting about it is this. First of all, it's not petrified, it's coalified. This is a tree trunk turned to coal, but you'll notice it has no roots and no tops. It's just a log. Is that correct? Kind of tells you it didn't grow there, doesn't it? Well, let's think about this. How did coal form anyway? You see, first of all, let's take a little look. Here you see some small coal layers or coal seams. Is that correct? But first of all, think with me. Do you notice it's flat on the bottom and flat on the top? Is that correct? So first of all, does anybody here see roots coming down from below these layers? No roots. It's flat on the top, flat on the bottom, Number two, you only find natural gas, coal, and natural oil between layers of sedimentary rock. Now, what is sedimentary rock? That's layers of dried out mud. So you only find natural gas, natural coal, natural oil between layers of dried out mud or some kind of sandstone. Now, this is a pure layer of anthracite coal. Now, anthracite coal is the hardest, densest, blackest, bestest coal there is. Anthracite coal is the really good stuff. But this is about 1.5 to 2 foot thick layer of pure anthracite coal, the really good stuff. Now, let's think. To get anthracite coal, you have to have 10-foot thick layer of plant and wood deposits compressed down to 10 to 1. Okay, so it takes 10 feet of material compressed to 1 foot to get hard anthracite coal. In our state of Utah, we have a pure layer of anthracite coal 200 foot thick. Now that tells you there had to be a layer of logs and vegetable material 2,000 foot thick there at some time in the past to be compressed down to 200. Is that correct? I would suggest to you only a worldwide flood could do that. A layer of logs and wood 2,000 foot thick all in one place, all at one time, would require a worldwide flood. And this is a bell found in 1944 in medium grade coal in our state of West Virginia, but the coal is supposedly 300 million years old. But this is a pre-flood bell used between creation 6,000 years ago and the flood of Noah by somebody, and trapped in the coal from the flood. And doesn't it take millions of years for fossils to form? I mean, now they taught me in those days at Berkeley that it takes millions and millions of years to get fossils. They told me that dinosaurs, been dead for 65 to 70, up to 150 million supposed years. But I don't believe that anymore. I don't. Now here's why. Well, let me show you a fossil. This is kind of an interesting fossil. It's called a Teddybearosaurus. Now this Teddybearosaurus fossilized, it only took 4 months. This was formed along the Thames River in England. There's a place where they have this overhang and a walkway underneath, and it's limestone rock, and there's water that comes over the limestone rock along the Thames River there, and people actually walk along underneath, and they tie tennis shoes and teddy bears and other things, Coca-Cola bottles, on long strings, and they come back, and 4 months later they have a fossil. You're not impressed? Well, how about this fossil? This is a coil of man-made rope, but this fossilized in only 2 weeks. Well, if you're not impressed yet, how about this? I think you'll agree, that is a fossilized fish, is that correct? But this fossil fish is quite interesting. You see, according to the evolutionists who found it, it died and was fossilized in less than 5 hours. Oh yeah. You see, this comes from Brazil. The Santana Formation was reported in 1989, but we found fossil fish with fossil gills, fossil muscles, fossil stomachs. The evolutionist paleontologist who found it did not allow his theory to get in the way of a good scientific observation. I applaud him for that. I really do. I really do. And he said this, quote, "What is clear is that the fossilization process took place moments after the fish died and was completed within only a few, probably less than 5 hours," unquote. But he went on to say this, in this case, quote, "Instantaneous fossilization," unquote, "is suspected to have been the very cause of death." Did you get that? What he said was, based upon what he found, the cause of death might well have been fossilization. So I guess it doesn't take millions of years to get a fossil, is that right? And then we have helium missing from the Earth's atmosphere. Helium is made in the crust of the Earth by the decay of radioactive material. It's the only way helium is basically made on Earth. Leaks out through the rock because it's an inert gas. It won't combine with anything else. It leaks out of the rock and into the atmosphere. Now, it is not lost into outer space. As a matter of fact, we actually get a slight addition of helium to the Earth's atmosphere by cosmic winds, but it's not lost into space. So whatever helium has been made on Earth is still basically here. The problem is this. though it escapes in the atmosphere and stays here, there's only enough for the atmosphere to be less than 2 million years old. Now I would find it problematic to have an Earth that was 4.6 billion years old, but an atmosphere that was less than 2 million. How about you? And here, there's too much salt in the Dead Sea. The Dead Sea has too much salt in it for it to be old. The north end today is 31% salt, the south end 37% salt. This is why you can't drown in it unless you strap on about 500 pounds of lead weights. But think with me for just a moment. All this salt would actually accumulate in less than 13,000 years. But evolutionists will tell you that the Jordan River Valley, this volcanic rift valley that we have here, they will say it is anything from 5 to 10 up to 20 million years old. If in fact the Dead Sea were, and the Jordan River Valley were 5, 10, 20 million years old, well, that means that the Jordan River flowing into the Dead Sea would have to be cleaner than distilled water for 20 million years. Anybody here ever seen the Jordan River? It's not that clean. But it simply shows that this is not 5, 10, 20 million years old. It's less than 13,000 and totally acceptable with only 6,000 or in fact 4,500, which is from the time of Noah's flood. I'm sure you've also all noticed that the moon is moving away, right? You all had noticed the moon is moving away, right? Where are your powers of observation, people? The moon is moving away from the Earth at a staggeringly fast rate. Come on, are you all ready to be staggered? Well, the moon is moving away at a staggeringly fast rate. It's moving away at 2 inches a year. Think with me for just a second. Today, you don't have to believe me. Today, you can prove this in a laptop computer, a desktop computer at home or the office. Now, do any of you remember something called the law of gravity? And the law of gravity says basically that as two objects get closer together, there's a stronger and stronger pull together. Is that right? Now, it's an inverse square law. You half the distance, you quadruple the force, and so forth. But you plug the formula into a laptop computer today, and you can prove to yourself, think with me, if the moon is moving away at 2 inches per year now, well, if I go back 1 year, it would be 2 inches closer, correct? Another year would be 2 inches closer. But as the moon starts to come back towards the Earth, well, then the force of gravity starts to increase. Is that correct? And the rate at which the moon comes back gets faster and faster, correct? Now, again, as I said, you can prove this in a laptop computer. If you go back in time, the moon would come back in, spiral in, and hit the Earth 1.4 billion years ago. Now, evolutionists say that the Earth and the moon are the same age. They say they're 4.5 to 5 billion supposed years old. Most of them say 4.6 billion. But if evolutionists were telling the truth, then that would mean that the moon was attached to the Earth for the first 3.6 billion years. Is that correct? And then it has been moving away ever since. Have I got that right? Now, there's something else I want you to notice here. If the moon comes back towards the Earth and the force of gravity gets ever larger, well, what's it going to do? Well, what is the major physical impact of the moon upon the Earth? It is tides, correct? Now, if the moon starts to come back towards the Earth, well, let's think about this. If the moon comes back towards the Earth, the tides would get higher and higher, correct? Right? Now, if you go back 1/2 billion years, and again, just on a laptop computer, well, the tides on Earth would rise 1 mile high twice a day. I think my first question would be, do you know how to breathe underwater? And keep in mind, if the tides rise 1 mile twice a day, just in your mind start thinking about erosion for just a minute, okay?